Why did the dinosaurs go extinct? Numerous fossilized bones, teeth, trackways, and other pieces of concrete evidence have shown that the dinosaurs inhabited Earth for at least 230 million years. However, no dinosaur bones have ever been discovered in strata younger than 66 million years old. At that time, as the Cretaceous epoch gave way to the Paleogene, it appears that all dinosaurs other than avians abruptly vanished from the planet. They were followed by all the flying reptiles known as pterosaurs, as well as dreadful sea reptiles like the mosasaurs, ichthyosaurs, and plesiosaurs. Much of the globe appears to have lost its ancient forests. While some mammals, birds, tiny reptiles, fish, and amphibians did survive, there was a sharp decline in the variety of the other living forms. Paleontologists have put a lot of work into piecing together what happened, and hypotheses on what killed the dinosaurs and the rest of the Cretaceous residents of the world have varied from the logical to the absurd. Two dominant theories are currently at odds in the scientific community. Did Earth-related problems cause the extinction of the dinosaurs, or were they victims of extraterrestrial conflict? Large, stony rocks called asteroids orbit the Sun. Their diameter ranges from a few to several hundred meters. A meteorite is any piece of an asteroid that survives impact with our planet. The most commonly recognized idea for the catastrophic extinction at the end of the Mesozoic era is the Alvarez hypothesis, which at first caused controversy. Paul asserts, since we've located the crater, we have pretty strong evidence supporting an asteroid impact on the ocean floor off the coast of Mexico. It is now mostly submerged. It is exactly the same age as the non-bird dinosaur extinction, which has been documented in rock records all around the planet. The Yucatan Peninsula in Mexico serves as the focal point for the impact site, also known as the Chicxulub crater. Thought to have been between 10 and 15 kilometers broad, the asteroid's speed during the encounter created the second largest crater on the planet, which is now 150 kilometers in diameter. In the so-called Cretaceous Paleogene, or KPG, layer, the geological border zone that seems to cap any known rock layers bearing dinosaur fossils, they have found a peculiarly high concentration of the metal iridium, which they use as their primary piece of evidence. The Alvarez family came to the conclusion that an alien object was responsible for the mass extinction because iridium is very uncommon in Earth's crust but more prevalent in stony meteorites. When scientists were able to connect the extinction event with a large impact crater off the Yucatan Peninsula in Mexico, the notion gained even more traction. The Chicxulub crater, which is around 93 miles wide, appears to be the appropriate size and age to explain the dinosaur die-off. In the so-called Cretaceous Paleogene, or KPG, layer, the geological border zone that seems to cap any known rock layers bearing dinosaur fossils, they have found a peculiarly high concentration of the metal iridium, which they use as their primary piece of evidence. The Alvarez family came to the conclusion that an alien object was responsible for the mass extinction because iridium is very uncommon in Earth's crust but more prevalent in stony meteorites. When scientists were able to connect the extinction event with a large impact crater off the Yucatan Peninsula in Mexico, the notion gained even more traction. The Chicxulub crater, which is around 93 miles wide, appears to be the appropriate size and age to explain the dinosaur die-off. Tellingly, the fossil-bearing layers contain loads of tiny glass bits called tektites, likely blobs of melted rock kicked up by the impact that solidified in the atmosphere and then rained down over Earth. Other experts, however, contend that the evidence for a significant meteor impact event is ambiguous and that Earth itself may be the most likely perpetrator. The Deccan Traps, ancient lava flows in India that were created between 60 and 65 million years ago, appear to be perfectly timed with the end of the Cretaceous period. The resultant volcanic rock now consists of strata that are approximately 200,000 square miles thick in certain areas. Such a huge eruption would have filled the atmosphere with carbon dioxide and other chemicals, drastically altering Earth's climate. Supporters of this idea cite several indicators that point to volcanism as being a better fit. One example is that, according to certain research, the Earth's temperature was changing even before the hypothetical impact occurred. With some indications that dinosaurs in particular were already in a steady decline in the late Cretaceous, other study has discovered evidence for huge die-offs considerably earlier than 66 million years ago. Furthermore, massive meteor hits are significantly less common than volcanic activity, which is a likely cause of other past extinctions. Supporters claim that if continuing volcanic eruptions were the primary reason for the global KPG extinctions, then everything makes sense. Scientists working to solve this ancient riddle are beginning to consider the possibility of combining various theories. It's plausible that the dinosaurs suffered a geologic 1-2 punch, with volcanism weakening ecosystems to the point where they were susceptible to an approaching meteor. The Deccan Traps and the Chicxulub crater need to be dated with greater accuracy before that idea can be confirmed. In 2019, 2 separate studies examined geochemical hints from the lava of the Deccan Traps and came to slightly different conclusions. One paper suggested that the volcanoes supported the demise of the dinosaurs by causing pre-impact declines, while the other suggested that the eruptions occurred after the impact event and may have only slightly contributed to the dinosaurs' demise. Years might pass before a conclusion is reached as researchers unearth new hints and create fresh methods for reconstructing the past. Regardless of the cause, it is certain that scientists investigating the demise of the dinosaurs are learning important lessons about the impacts of extreme climate change on Earth's people.